Ever wondered what the difference between machine learning, traditional AI, and generative AI is? Well, you're not alone. In the vast digital landscape of today, artificial intelligence has taken center stage, revolutionizing countless industries and aspects of our daily lives. Now, let's break it down. The artificial intelligence universe is primarily composed of three main branches: machine learning, traditional AI, and generative AI. Each one of these branches has its unique characteristics, applications, and complexities. Firstly, machine learning, a subset of AI that enables computers to learn and adapt through experience. Then, we have traditional AI, often rule-based systems designed to simulate human intelligence. Lastly, there's generative AI, the innovative frontier of the AI world, capable of creating new content from scratch. Each of these branches of AI holds immense potential to shape our future. So, stay tuned as we dive deep into the fascinating world of artificial intelligence. First off, let's unravel the mystery of machine learning. Machine learning is a branch of artificial intelligence that empowers computers with the ability to learn and adapt. It's all about data, lots and lots of data. By feeding a computer system a wealth of information, we allow it to learn patterns and make informed decisions. Imagine you're teaching a toddler to identify a dog. You'd show the child numerous pictures of dogs, point out the common features, and repeat the word dog. Similarly, in machine learning, we feed the system thousands, if not millions, of data points, and let it figure out the underlying patterns. Here's where it gets truly fascinating. A machine learning algorithm learns from its past experiences. It's like a self-improving system. It gets better at its task over time without any explicit programming. For instance, a spam filter that uses machine learning gets more adept at catching unwanted emails the more it operates, learning from the ones it missed and the ones it correctly identified. Now, there are different types of machine learning models. Supervised learning, where the model is given a set of inputs and their corresponding outputs to learn from. Unsupervised learning, where the model is only given inputs and must find structure in its input all by itself. And reinforcement learning, where an agent learns how to behave in an environment by performing actions and seeing the results. The applications of machine learning are boundless. From predicting stock market trends and diagnosing diseases, to powering your Netflix recommendations and your smartphone's voice assistant, machine learning is reshaping our world in ways we experience every day. So, in essence, machine learning is about learning from data and making predictions or decisions without being explicitly programmed. It's about giving computers the ability to learn and evolve, much like a human does, and that's what makes it such a powerful tool in the world of artificial intelligence. Moving on, what exactly is traditional AI? To understand this, let's take a step back in time. Traditional AI, also known as classical AI, was the forerunner in the field of artificial intelligence. It's like the grandparent of the AI family, having paved the way for newer generations of AI like machine learning and generative AI. Traditional AI operates on a rule-based system. Think of it as a sophisticated set of if-then statements. If a certain condition is met, then a specific action is taken. This is very much like the way a flowchart works. Now, you're probably wondering, how does it actually work? Well, the mechanics of traditional AI are quite fascinating. It relies heavily on preset instructions. These instructions are meticulously designed by programmers to guide the AI in making decisions and solving problems. Imagine a chess game. A traditional AI designed for this purpose would have a set of rules and strategies programmed into it. If the opponent makes a certain move, the AI knows exactly how to respond because it has a preset rule for that specific scenario. This rule-based system is what sets traditional AI apart. While it may sound simplistic compared to its more advanced AI relatives, it's important to remember that traditional AI has its own unique strengths. One of the key strengths is its predictability. Because it operates based on preset rules, its actions and responses are always predictable. This makes it a trusted tool in scenarios where predictability and consistency are paramount. Another strength is its efficiency in well-defined domains. Traditional AI excels in environments where the rules are clear and unchanging. Think about automated customer service bots or GPS navigation systems. These applications thrive on the rule-based approach of traditional AI. However, traditional AI isn't without its limitations. Its reliance on preset rules means it struggles with ambiguity and can't learn or adapt from new experiences like its AI counterparts. In conclusion, traditional AI is a master of rules, thriving in well-defined environments and offering predictable outcomes. Its role in the evolution of artificial intelligence is pivotal, serving as the foundation upon which newer models of AI have been built. Traditional AI, therefore, is all about following instructions to the letter. And now, let's delve into the realm of generative AI. Generative AI, as the name suggests, is all about creation. It is a subset of artificial intelligence that leverages machine learning techniques to generate novel and original outputs. But how does it do this? Well, it's all about training. Generative AI models are trained on a wealth of data, learning the patterns, nuances, and structures within that data. Once trained, these models can generate new content that mirrors the style and complexity of the training data, but is entirely unique. Imagine a painter who has spent years studying the works of Monet. She understands his use of color, his brush strokes, his subject matter. Now, give her a blank canvas and she can create a new painting in the style of Monet. But it's not a copy, it's entirely her own creation. That's what generative AI does, but with data instead of paint. But what does this mean in practical terms? Well, the capabilities of generative AI are vast and varied. It can create anything from a piece of music in the style of Mozart, to a new episode of your favorite TV show, to a piece of art in the style of Van Gogh. It can even generate realistic human faces or design new pharmaceutical drugs. It can even generate realistic human faces or design new pharmaceutical drugs. The possibilities are nearly limitless. However, it's important to remember that generative AI is still a tool. It doesn't have consciousness or intent. It's not truly creating in the way a human artist or scientist does. It's following patterns and rules it's learned from its training data and generating new content based on those rules. Also, like any AI technology, generative AI has its limitations. It's only as good as the data it's trained on. If the training data is flawed or biased, the output will be too. It also can't understand or interpret the content it creates in the way a human can. It doesn't know if a joke is funny or if a piece of music is beautiful. It just knows how to generate content that fits the patterns it's learned. Generative AI, thus, is the creative cousin among AI technologies. Having explored the three AI varieties, how do they compare and contrast? Machine learning, traditional AI, and generative AI each have their own unique strengths, weaknesses, and application areas. At a fundamental level, machine learning models learn from data, identifying patterns and making data-driven predictions or decisions. On the other hand, traditional AI, also known as symbolic AI, relies on predefined rules and logic. It's like an expert system that uses if-then rules to simulate human intelligence. Generative AI, the third variety, merges aspects from both machine learning and traditional AI. It learns from data like machine learning models, but instead of making predictions, it generates new data that mirrors the original dataset. Now, let's dive a little deeper. Machine learning shines in its ability to handle large, complex datasets and make accurate predictions. However, it lacks the ability to explain its decision-making process, which is a key strength of traditional AI. Traditional AI, with its rule-based approach, can provide clear reasoning for its decisions, but struggles with complex, unstructured data. Generative AI stands in the middle ground. It can handle complex data and generate new, creative outputs. From writing poems and songs to designing new products and fashion items, the possibilities are endless. But it's not without its limitations. Generative AI models can be unpredictable and require vast amounts of data to train. Moreover, there are ethical concerns surrounding generative AI. The ability to create realistic yet artificial content has led to concerns about deepfakes and misinformation. But, with responsible use and proper regulation, the potential benefits outweigh the risks. Despite their differences, all three AI varieties share a common goal: to automate, simplify, and enhance tasks and processes. The choice between them depends on the specific needs and constraints of the task at hand. In the end, it's not a matter of which AI variety is best, but rather which is most suitable for a particular application. Despite their differences, all three AI varieties share a common goal: to automate, simplify, and enhance tasks and processes. But how do these AI varieties impact our daily life and work? From our smartphones to our workplaces, AI is everywhere. Machine learning powers recommendations on streaming platforms, predicts traffic on navigation apps, and even assists in medical diagnoses. Traditional AI, with its rule-based systems, is the backbone of many industrial processes, automating tasks and improving efficiency. And then there's generative AI. It's behind the creation of realistic virtual worlds in video games, the generation of unique, personalized advertisements, and even the crafting of music and art. It's also making waves in fields like pharmaceuticals, where it's being used to predict the properties of potential new drugs. From technology and entertainment to healthcare and manufacturing, AI is not just participating, it's leading the way. It's transforming how we live, work, and even think. As we've seen, AI is not just a futuristic concept, it's here shaping our world in countless ways.